I'm a geochemist by profession, and I used different chemicals, as you see, to understand different processes. So I work a lot with chromatographic techniques, and then I thought that why don't I use this knowledge and transfer into product, and that's how I kind of co-founded the Earth Phase Analytics. Both the water quality and the quantity is a big problem for our nation. So I focus on the quality aspect of it. Now when we say water quality, it can be of many arms, like biological pollutants are there, like E. coli, virus, bacteria, then you have organic pollutants, pesticides coming from fertilizers. And then there is one more group of pollutants which I work on, is mostly the heavy metals like chromium, copper, lead, arsenic. For example, the Kanpur belt, if you look at the tannery industries are there, so there's a lot of chromium pollution here. Similarly, if you go to the Indo-Gangetic plain, arsenic pollutions are there. Now the government, what it requires, effective monitoring technique. So how do we monitor this pollutant? That's why we came up, based on the chromatographic technique, we came up with this product that can kind of shift the entire way the monitoring of heavy metals is done in India. Just to show you, for example, if I want to measure the chromium concentration of the water out here, now as I said, you go to the field, you fill up these bottles, you ship it. Now imagine you want 500, a very high resolution monitoring of a region. It is really difficult for you to ship 500, thousands of bottles like this. It's not cost effective, and also it requires large trucks to transport. So that's why we came up with this small device that we are working in together with the Massachusetts Institute of Technology. This is actually based on the dry blood sampling technique. How this device works, as you can see, it's a few centimeter long device. So what we do is, this is the bottle where your contaminated water is. So what needs to be done is, you put the device inside like this, and then you just do mechanical stirring for 2 minutes. So there is no power requirement, anyone can do it, it's very user friendly. And then after 2 minutes of stirring, what happens is, this cation exchange resins, it has a very high affinity for the chromium or whatever the desired metal that you want to take up. So the uptake, all the dissolved metals in this water will be taken up, and then you basically kind of take it out, dry it. You can just ship this one, and then we bring it back to the lab, and then we can elute it from the resin, and we can get a good measurement.